Alyssa, and this is my second assignment for big data technologies. I'll just go through what I did. More specific details are found in my documentation as well as looking through my code and my expected output in the documentation. Okay, we'll go through it. First is data curation. We were given a JSON file with incorrect format. Specifically, it had object ID number long, which can't be used when uploading into Neo4j cipher. So we want to clean that out. We used regex. You can read my documentation for more first the details, but yes, we used regex to remove it out. We then after that used that edited JSON file and cleaned it even further to remove unnecessary fields or fields that I believe aren't not needed based on the questions given. So first we have our sample dictionary containing all the information that we need. The way we cleaned it is we upload the original JSON file without the object ID number long. We split the data for each tweet based on the specific regex, which is the comment before the tweet. We then load it and then we pass it through the clean raw tweet method, which contains this and formats it that way. And then we append the output into a list. That list then is dumped into a JSON file. So that's how we get clean tweets. We do the similar format with another file called filtered tweets. Filtered tweets only contain tweets that have the verb share, because we want to use this file to create the retweets later on. So now we go to part one, initial graph data model. So we needed to make the tweets, users, hashtag, source, and link. So it has this as the graph data model, which mimics the graph data model I created right here. If I click, yep, there we go. That has all of the needed nodes and their relationships. To create this, we can look through my code just so that we can understand it. For tweets, and this also applies for all of the other nodes, we start with a with statement containing all the fields that we want to keep and save. We have a merge statement, which basically creates that node if that particular node does not exist based on this particular ID. And this is the information we want to save. This is done as well for user. When creating a user that posts a specific tweet, we have a match if that tweet exists, and then we create a user, and then we basically create the relationship and also of course save all the necessary information. The more unique part here is the for each statement. So it loops through basically a list of user mentions. It creates the user if it doesn't exist yet, and on that create we save the necessary information and the relationships. Hashtag, link, and source information is all in Twitter entities, which I shortened to entities, and it's basically a list. So we also have to do a for loop for each of those to create the nodes, which is what I did. And at the end, we have all those nodes. Now to create the retweets, the different part is I used filtered retweets as the JSON file, and I look specifically under object. Object has all of the information in the original tweet, and the caveat here is some original tweets might not be a part of the original dataset, and thus we have to create them. We can also create a relationship between this original tweet and the retweeted tweet with the word retweets. So this is how it's made. We basically just copy the code from the previous, and we just add the retweets, and we also create the retweet if or create the original tweet, which I labeled RT if it doesn't exist yet. And we also make the necessary change, save the necessary information for user, hashtag, links, and source. Okay, now to move on to the next part, which involves querying. First, we have the find the top 5 most used sources for apps in our site to post and share a tweet. So we basically have this. We have a match statement, and then we count the number of posts and the count number of distinct users, and then basically return them and order it by number of posts with the limit of 5 because we want to keep the top 5. And then we get a specific result. Let me just copy and paste it over here. We get this result with iPhone, client, and Android being the number one, or the top rather. Next, we have the second question, which requires us to get the users' top 3 users that have the highest number of tweets with a retweet count greater than 50. For each of these users, show the number of popular tweets that they have. So this is the code. The unique thing about it, it has an unwind. So we divide it in 2 parts. First, we get the top 3 users with the most, where the retweet counts greater than 50. We collect all their popular tweets and we count the number of tweets they have and get the top 3 basically. And then once we get the top 3, we unwind the tweet so that we can get the hashtags and then collect the top hashtags over here, which returns this result, which I think I can show you over here. Next, we get the shortest path. So to understand it is first we use the method shortest path, where the user has a preferred username of Lucky Sivan and the hashtag is I'm so sick, and we have a where statement that says that if none of these relationships have the type using, which is what was indicated in the question, we return the specific path and the path length, which I think the result is 24. Here's the path as indicated by my documentation and the path length 24. Next, we move on to part 3. So we suggest a modification to the base data model that will make it easier to answer the questions such as show me the top 5 users, posting links from realestate.com, discuss any options you considered. Well, the first option I considered is making not really a modification onto the database model, but more of the query. So as you can see here, we can just have the contain statement, which basically looks through the string and see if any of this, if there's a substring that has this, and it returns the result. But the modification that I considered is basically saving the domain. So this is considered the domain. We can find it in the URL or extended link. So what we did here is we split it and basically saved that chunk as the domain. What I like about this method is we don't have to constantly type contain something. It's already a domain, so it just makes it easier for us to query. I'm just creating it right here. It looks like this. It connects from link, and then I also made a connection to domain so that it would be easier for me to query. And oh, I wonder why, but it basically returns this result. Sorry about that. I forgot to match, I think. There you go. Same as the previous result. It's just a shorter query and you don't have to always do contains. Next, we have using the elements of your extended data model, answer the following questions. Where the user posts most links from LinkedIn, or which is indicated with linking.com or link.in. So we have this, and it returns this as the result. I'll just show it here. We create a list, and we basically check if any word is in that list, and then we basically count the number of users that have a specific number of posts of any that have LinkedIn. After that, we have in part C, which is the last part, suggest a way to just make it easier. So what I did is I created an organization one, so that you could you don't have to do the list anymore. It's already connected basically to a specific domain. Specific organization. So you can just query the organization directly. You don't have to do a list anymore. And I think to get the subtype for industry, you can either save it as a field in the organization, or you can also make another node that connects to organization right here. So yeah, that's how I tackled